Hi students, I thought we would do this quick little review of Lewis Structures quiz that I found online. So here we go. Which of these is the correct Lewis structure for hydrogen peroxide, which is H2O2? So some things we want to remember here. Hydrogen always likes to have 2 valence electrons and only 2. So we may be able to answer this question strictly based on that. So because hydrogen wants 2 valence electrons, it likes to form one bond. So let's look at this up close. So we have here one bond on this hydrogen, but this hydrogen has 2 bonds. 2 bonds, remember each bond is 2 valence electrons. So 2 bonds would be 4 valence electrons. Hydrogen does not want 4, so it's not going to do that. So this one is wrong. This one shows each hydrogen with 2 valence electrons and, one bond each. So that looks maybe good. This one shows this hydrogen with a bond and also another bond, and this hydrogen also has 2 bonds. 2 bonds is 4 valence electrons. That's not correct for hydrogen. And here we also have hydrogen atoms that have 2 bonds attached to them. They only want 1. So hydrogen atoms have to always hang out on the outside of a molecule because they only want 1 valence electron. 2 valence electrons, so that's 1 bond. So this is going to be our correct answer, and we didn't have to do much math on that one. Okay, on this one, we're looking for diatomic nitrogen. If you watched the first video, you probably know the answer to this already. But N2, first thing we want to think about is how many valence electrons each nitrogen atom is going to be bringing to the table here. So if you look up on your periodic table, nitrogen is over here. There it is. It has 5 valence electrons. So 5 valence electrons, 2 of those, that means we need 10. So we're going to count and see which of these molecules have 10 valence electrons. And if we find one with 10, then that's probably our answer. Whoa, that got smaller. Let's take a look at this first one. So each dot is 1 valence electron and each line is 2. So here we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this may be our answer. Here we've got 4 bonds in the middle. That's 2, 4, 6, 8, but that's not enough electrons shown, so that can't be right. Here we have 2, 4, 6, 8, 10, 12, 14 valence electrons. That's too much. 2, 4, 6, 8, 10, 12. That's not correct either because we said we needed 10. So that is our correct answer. Okay. This one we're looking for the diatomic fluorine molecule. Remember the gens and the enes are diatomic, so it's always, you never have a single atom of that substance. They will pair up. So fluorine is a halogen. Halogens all have 7 valence electrons, and we have 2 of those. So that's 14 total electrons that we need. So let's see what we got here. Here we got 2, 4, 6, 8. Nope. 2, 4, 6, 8, 10. Nope, we need 14. 2, 4, 6, 8, 10, 12. Nope. 2, 4, 6, 8, 10, 12, 14. And there's our answer. Okay, which of these is the correctly drawn Lewis structure? So this one gets a little more tricky. First of all, we're going to look to make sure we don't have any hydrogens in the middle bonded to 2 different things. And here, all of our hydrogens are terminal atoms. They're on the ends, so that's okay. Here we have some hydrogens that are terminal atoms and another one over here. That's okay. Those hydrogens are okay. Okay, so hydrogens are not an issue here. So now we need to think about how many total valence electrons each atom wants. So each atom wants 2 valence electrons. And in our first picture, hydrogen each has 2. Carbon wants 8. And so carbon has 2, 4, 6, 8 in its 4 bonds. So that's okay. Oxygen also wants 8. So 2, 4, 6, 8. So that looks like it might be correct. Let's see if we can eliminate any others on that basis. This one we can eliminate because carbon has 5 bonds attached to it, which would be 10 valence electrons. It wants 8. It does not want 10. So we ruled out this one. We'll call this letter B. It's the second one here. So we can rule that one out because the carbon has too many bonds. This one, the carbon has 4 bonds, so that's 8 valence electrons, so that's okay. And oxygen has 2, 4, 6, 8 valence electrons also, so this one might be okay. So now we're between B and C. And let's look at D and see what we think about this. With letter D, I'm going to say this one's definitely wrong because we have carbon again with 5 bonds. Carbon wants 4 bonds, not 5 bonds. Okay, so it's either A or C. So now we have to decide how many valence electrons we should have in this picture. So on this one, carbon atoms, look them up on your periodic table. They each have 4. So that's 4 valence electrons, plus each hydrogen has 1. So that's 5, 6, 7. Plus oxygen has 6. So 7 and 6 is 13 valence electrons, which is what we should have here. So we have 2, 4, 6, 8, 10, 12, 14. So that somehow has gotten a hold of an extra electron. So that's probably not right. Let's check and see if we're okay here. Here we have carbon with its 4 valence electrons and 2 hydrogens with 1 each, plus an oxygen, so that's 6, plus an oxygen which has 6, so this should have 12 valence electrons. This has 2, 4, 6, 8, 10, 12. So that is correct. That is our correct answer. Okay, let's do just a couple more here. This one says, which is correct for CF4? CF4, if there's a single element like the C in CF4, it doesn't have a subscript number, it has to go in the middle. So this guy is definitely wrong. This one might be right. This one's got C in the middle also, so that might be right. And this one has C in the middle, but boy, that's got a lot going on. Well, let's come back to that. Okay, we ruled out A. Let's have a look at B. So for this one, we need to count our valence electrons again, and also double check and see if we have 8 in the drawing. So the carbon atom has 4 bonds, so that's 8 valence electrons, so that seems good. And each fluorine wants 8 valence electrons as well. Remember, hydrogen's really the only element that wants 2. Everybody else wants 8. So each fluorine atom has 2, 4, 6 pairs, lone pairs of unshared electrons, and then they also have a bond. So that makes 8. So this may be okay. The other thing, let's see if we can rule out any of the others. We said it wasn't A, so it might be B, it might be C. Okay, so this one I think we can rule out because carbon has 8 valence electrons, but each fluorine only has 2. Fluorine's not happy with that. And on this one, 2, 4, 6, 8 for fluorine. All the fluorines look okay. And all the carbons look okay, or the one carbon looks okay. So, okay, we're ruling it down to B and D. So now we have to do the math. So carbon has 4 valence electrons, and each fluorine has 7, and there's 4 fluorines. So 7 times 4 is 28. Plus 4, so that's 32. So do we have 32 electrons represented in this picture? 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32. Yes, we do. So this is probably our answer. This one is probably our answer. But let's check the math here. We should have 32. We've got 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28. So that is not the right amount of electrons. So B is definitely our answer. And let's do one more and then we'll wrap up the quiz here. So this one, we have C2H6, C2H6. Now we know, let's see, we can look at letter D here and rule that out immediately because here we have a hydrogen in the middle. Hydrogens never go in the middle, they're always terminal. This one we can rule out because each hydrogen only wants 2 valence electrons, and that's way too many. Same thing in this one. So our answer, of course, is B. All right. If you have any questions, let me know. I'm going to share this link so you can go through the whole quiz if you'd like to before you do today's check for understanding.